Hello everybody. Last video, we learned about the exponent rules and we did some examples that were doable and smaller and nice. Today we will start doing some problems that are a little bit more advanced. So an example is this first one right here. So let's get started. So first thing I do is I notice the coefficients. -7/3. Unfortunately, these numbers do not simplify, so I know my next step, I'm going to leave those alone because they're just not going to simplify because I can't divide them. Next thing I'm going to do is I'm going to look at my a's. So maybe we can go ahead and get started. So I know if I have a squared over a cubed, I know that I'm subtracting, which is a squared over a cubed is 2 minus 3, which is a to the power -1. And I know that in order to make that negative exponent positive, I would have to flip it, and the a ends up on the bottom. So if you think about me just doing this individually, you can kind of see how I get an a in the denominator. And if we look at the next one, which are b terms, which is b cubed over b to the fourth, 3 minus 4, which is b to the power -1. And the same thing, flip it, that ends up on the bottom. And then I could go ahead and subtract these, but I also understand that c to the power of 0 is just 1. So if that's just 1, I mean, I'm just going to leave c cubed on the bottom, and this is what I'm left with. So normally with these problems, you always want to start inside and then work yourself out. So now what I'm going to do is I'm going to assign all my numbers and variables that do not have an exponent a 1, because we got to make sure that this -4 will multiply every single exponent. Of course, my arrows make it look a little bit more confusing, but all I'm trying to show here is that you are taking that number and multiplying it. So the weird thing about this first one is it's actually -7 to the -4 power. And the reason for that is because you're doing -7 times -7 times -7 times -7, which is going to end up being positive. So it's really important that you put that -7 in parentheses because you're doing that 4 times. And then on the bottom, I'm going to be 3 to the power -4, a to the power -4, b to the power -4, and c to the power -12. So this is a doozy because we got everything with a negative exponent. So we know to undo this, we're just going to flip everything completely. So on top, it's going to be 3 to the 4th, a to the 4th, b to the 4th, c to the 12th. And then I'm going to have a -7 to the 4th. A lot of people might be surprised. Oh, why did that -7 not change? You have to remember, y'all, it's called the negative exponent rule, not the negative base rule. That is not going to change that value at all. And I could evaluate 3 to the 4th. I could evaluate -7 to the 4th. But for now, I'm just going to leave this as my answer and call it a day. The important thing here is that we know how to deal with the exponent rules. So that would be our first problem. Moving on to number 2, the first thing I'm going to do is I'm going to take that 4 and I'm going to give it a 1, just because I know I'm going to take this 3 and multiply everything. So I end up with 4 cubed, x to the 12, y to the -12. This is the only part that has a negative exponent, so I know that I need to move that to the denominator. Remember also that 4 cubed means 4 times 4 times 4. So that's why we're getting 64 and not 12. Because 4 cubed means 4 times 4 times 4. So that's how you would do number 2. It gets fun the more and more you do this. I look at it as a nice challenge. So next, we have 3 divided by 12. So we can definitely simplify this because 3 goes into 3 one time, 12 goes into 3 4 times. So 3/12 is equivalent to 1/4. And then next, we have, I keep doing that, sorry. And then we have our x's. So x is second. And you see how I do a lot of this work? Sometimes on my scratch work, I do 2 minus 6, which is x to the power negative 4. So I know I'm going to take that and I'm going to move it to the bottom. So I know that becomes x to the 4th. Sometimes doing it to the side is just cleaner and it's better than just doing everything in your head and not thinking about it. Same thing with my y's. I'm going to be careful with my y's, especially be careful when you have negatives for some reason. So this is y to the power of negative 3 minus 3, which is y to the power of negative 6. And we know that in order to make this positive, you put it over 1 and you flip it and you get y to the 6. And this is our final answer. Nothing else has the same base, so we cannot apply any other exponent rules. The last example involves rational exponents or just our fractions. Just want to highlight some nice characteristics of this problem. So just highlighted those. I'm going to take them out. So I want us to focus on a bigger thing, which is this right here. This 16 to the 3/4 power is something that we reviewed last video. And this might be something worth doing on a scratch paper to the side. I know when I look at 16 to the 3/4, I don't know what this is off the bat. So I convert it into radical form, which is the 4th root of 16 to the power of 3. What same number do I multiply 4 times to get 16? Well, that's a 2. And then 2 cubed is 2 times 2 times 2, which is an 8. So I know so far I have a 3 on the top and I have an 8 on the bottom. So I can put a check mark under this because I just took care of probably the most confusing looking term on this page. So now how we deal with everything else is really, really dependent on you. Some people would tell me you could use the quotient rule and subtract these. So this could be x to the power of negative a half minus 2. You could do that. I'm going to do a little something different just because, we can. Some people will be like, well, if x squared is on the bottom, I'm going to move the x to a half from the top to the bottom because I know that if I have a negative exponent, I can move it down and make the exponent positive. Some people choose to do that because they like positive exponents. So let's continue that trend. Sorry. We know that y to the power of 0 is just 1, so we don't have to worry about that. And we know that y to the power of negative 3, that we can take this part and just move it to the top. So we know that becomes positive. I'm going to leave my z to the power of 1/3. And then I'm going to take z to the negative second power and also move it to the top. I encourage you to do the way that makes the most sense to you, the way that you think will lead you to success. I just don't want to show you the same way over and over again. A lot of people just do the quotient rule and go down. There's nothing wrong with that. I just chose to get rid of all the negative exponents from the beginning and kind of see where this takes me. So now I have two things. I have this I can simplify, and I know I can do this by adding, and I have this that I can simplify, and I can do this by adding. So I end up with 3/8 y cubed z to the power of 1/3 plus 2, x to the power of 2 plus a half. So this is what I have. And now I'm going to put this over 1, put this over 1. Let me actually rewrite this one on the bottom. I made it look a little too short. So it's 2 over 1 plus 1/2. If we know anything about adding fractions, we know we need to make them the same denominator. So I'm going to multiply the top and bottom by 3 here. I'm going to multiply this by 2 here. So you're going to get 3y cubed c to the power of 1/3 plus 6 over 3 over x to the power of 4 over 2 plus a half, which is 3y cubed c to the power of 7 over 3 over 8x 5 over 2, and you are finished. Some people like to do that work to the side, like let me just take 1/3 and add 2, make that my scratch paper, and then write my answer. Some people do it the way I did and kind of showed the steps right here and showed the steps right here. Once again, whatever feels natural to you. That is the end of the video. Pretty much everything we do is just a variation of this. You just have to pay attention, check your work, and of course, have some fun. Have a great day.